Greetings, we're going to go over some basic factoring identities, algebra identities, if you will. And yeah, like to solve a lot of the algebraic problems, like it's good to have like a good intuition about some of the identities that we use in algebra. It just makes everything a lot more sense, you know. We're not just going along just memorizing equations. We're actually trying to understand this a lot better. So, our first identity, which is actually the hardest one, I would say, is a squared minus b squared equals a minus b and a plus b. So there's different ways you can do it, and the way you can think about it as a squared is a square, right? It's a times a, which is base times height, right? This is my square, a square. Its base is a, and its height is a, right? And then we're going to subtract a negative b squared, right? A negative b squared term. Now, in this case, we're going to assume that b squared is smaller than a squared, right? So it's a smaller rectangle embedded in this larger square, a smaller square embedded in this larger square, which is a squared. And we're going to subtract it, right? So, in essence, the area that we're going to be looking at, that we want to compute, is everything but b squared, right? So we want all this part that is shaded. Okay, and there's many ways we can go about it, right? There's a long way where we can first calculate the area of this rectangle, this square, and you can see that its base is a minus b, right? The total length of this is a, but if you subtract the length here, which is b, we have a minus b. And the same thing goes for the height. We have a minus b for its height. So in total, the area of a1 is going to be a minus b times a minus b. Now, area 2 and area 3 are going to be the same. They're just, they're just flipped. Okay, so the height, we already know that is a minus b, and now the base, we know that it is b. Okay, you see the height of this is a minus b, and then the base is b. So we have a minus b times b. Okay, so what about area 3? Well, we know that its base is a minus b. You see it's the same basis below. And then its height is b. So what we have here is area 3 is b times a minus b. Okay? So these are 3 areas, and their sum constitutes this shaded area that we want to look at. Okay, and so we have a squared minus b squared equals this right here, right? Again, these are the same. You can just move it to the other side, and we get the same terms, right, for the same area. So we get this 2 here. Okay, but this is kind of a bit hard way, and also, it looks like it just makes the equation a bit harder to understand and just use. So there's actually another trick that we can use, and it's going to consist on taking this rectangle here, which has base a minus b and has height b. Okay, and we want to move it down here. Now we can't just move it like so because its height is b, and its base is a minus b. We want it so that its height is the same thing as the height of a2 here, right? Okay, now we know that the height of a2 is a minus b, right? But we know that the base of a3 is a minus b. So what we're going to do is invert it so that we have its height as a minus b and its base b. Okay? And that's what I've done down below here. So I've taken this, flipped it around, and then just stuck it together. And you see all these rectangles here and squares have the same height. Okay? That's important. So now we don't care about the areas of these rectangles and squares above. And we're left to only calculate the area below, right? So what is the area of all of these, of this whole rectangle here? Well, we know its base. Well, how do we know its base? So up to here, we know this the length is a. Now we added this term over here, this rectangle, which we flipped. So now the base of this rectangle is going to be b, right? So the total length of this base is going to be a plus b. All right? Now, the height of this whole rectangle is going to be a minus b, right? So in total, we have So the area of this whole thing is going to be base times height, which is a plus b and a minus b. Okay? And that is going to be the same thing as a squared minus b squared. Okay? So that is one of the first identities that we're going to use probably throughout your mathematical education. So it's good to know where it comes from, and yeah, it's a lot of fun. Okay, so that is our first identity. Our second identity is going to be a plus b squared equals a squared plus 2 times a times b plus b squared. So we have this. Okay, and now where does this come from? Well, imagine you have the following construction, right? You have this larger square whose height is a plus b and whose base is a plus b as well, right? So the total area of this this square is a plus b squared. Okay. Okay, but now we can also break it down a little further. So since it's a plus b in the base, we know we can have like a section whose area is a. And now in the height, we know that the height is a plus b, so we can leave a section of height h. So we can draw this square of area a squared, right? Its base is a, its height is a. Okay, what about this b term? Well, since we have a plus b, we have a height of b, and then since the base is a plus b, we have a base of b here. So then our area is b squared. Okay? And now we have these other side rectangles. So this other side rectangle, remember that our base of a squared is a. So then we have this base a, and our height is going to be b. So our area is b times a. And the same goes for here, right? Our height is a, our base is b, we have b times a. Okay, so in total we can add all these individual areas together. So we have a squared plus ba plus ba plus b. And so these are the same, they're just multiplied on different sides, and because they're numbers, we can just move them around. So we have 2ba, meaning that we can commute them, meaning that we can do this, ab equals ab, right? They're just numbers, so this is possible. Okay, so we have our identity here, a squared plus 2 times ba plus b squared. Okay, and yeah, just maybe take a moment to maybe understand that if you're having trouble. So the height is a plus b, right? The height is a plus b. The base is a plus b. And we're able to like cut it into these 4 components, right? Okay, just maybe pause this video and look at it, make sure it makes sense. Our third our third identity is going to be a minus b squared. Okay, so imagine we have a total rectangle. Instead of being a plus b, our rectangle is going to be a base a, and a height a, okay? Not a plus b. And now what we want to do is we want to find the area that's right here. Sorry, this is a bit messy here. So why is that? Well, you see that we're going to subtract by this term minus b. And so minus b, because it's, so let's just write it. So we have a squared, this equals a minus b times a minus b. And so you see my height is being reduced by b, and my base is being reduced by a term of b here, right? Okay, so that means that in total my square becomes a lot smaller. So we're reducing my base by b, right? Which leaves me a minus b, and we're reducing our height by b, which gives me a minus b. So the area that we want to find is this one right here. Okay? All right. So I know it's a bit messy, but okay. So how do we do that? And you can go about it many different ways, right? You can subtract this b squared term here, subtract maybe this side and this side. But this height here is a minus b, the base here is b. You could subtract by this area, which is a minus b times b. You can subtract this area, which has base a minus b and has height b, and this other square, which is b squared. Okay, so we have a squared minus a minus b times b minus a minus b times b minus b squared. But this is like really long and kind of complicated. But we want something a lot more. Oh, well, actually, this will actually suffice for now. So how can we rewrite this in maybe an easier term? Because this is actually the solution, right? This is the solution of the area of this here. But it's a bit long and tarsed. What we actually want to do is maybe find this other identity, which is a little bit easier to understand. Okay? And so let me just give you a brief, maybe, summary of what it does is, so we have our base, which is b, and we have our height, which is a. And we're just going to subtract by this whole thing, which has area a times b, right? Okay. Now, the other term that we have to subtract is this here, but we're kind of lazy, so what we're going to do is subtract this whole term down here. And here the base is a and the height is b. So we have a times b, right? So we have our total rectangle, our total square, which is a squared. And we're subtracting ab and subtracting ab, right? Now, you might have noticed something that when we subtract this part and then subtract this again, we're subtracting this area right here, which is b squared, twice. And we don't want to do that, right? We only want to subtract it once. So what we're going to do is add a term of b squared to, compensate. So in total, what we have here is a squared minus the first area that we subtracted, ab, minus the second area that we subtracted, another ab. And then to compensate for over subtracting, we're going to add a b squared term. Okay, so we're left with a squared minus 2ab plus b squared. Okay, so those are the three identities that you have in your PDF, and hopefully this helps you understand these identities better.